Imagine building a powerful race car. You can choose the engine, assemble the frame, even design its aerodynamics. But if you don't tune the car, it won't win. Artificial intelligence works the same way. Under every machine learning model lies a set of mysterious dials, hyperparameters. They decide how fast the model learns, how much it remembers, how well it generalizes, and how it reacts to noise. And here's the twist. Even the best model fails if these dials are wrong. But tuned correctly, you unlock performance jumps so dramatic they feel like magic. Today, you and I are going under the hood to reveal the art and science of hyperparameter tuning. What are hyperparameters really? Hyperparameters are not learned by the model. You choose them before training. Think of a machine learning model as a student. Hyperparameters define how fast they study, how much they forget, how often they check their answers, and how complex their notes are. Examples: learning rate, batch size, number of layers, number of neurons, dropout rate, number of trees, kernel type, temperature. If training a model is baking a cake, hyperparameters are the oven temperature, baking time, and mixing speed. The recipe changes everything. Why hyperparameter tuning is a game changer. A poorly tuned model can overfit, underfit, learn too slowly, explode or diverge, give unstable predictions. A well-tuned model converges faster, avoids overfitting, generalizes better, becomes more robust, reaches hidden accuracy potential. Real example: a simple neural network on MNIST. Wrong learning rate, 10% accuracy. Good learning rate, 98% accuracy. Same model, different dials. The core hyperparameters and how they influence training. Learning rate, the most sensitive hyperparameter. Think of it as how big each step is in the loss landscape. Too high, model jumps around, never converges. Too low, painfully slow learning. Batch size affects stability and memory usage. Small batches, noisy updates, but better generalization. Large batches, smoother updates, but risk sharp minima. Number of layers and neurons controls model capacity. Too small, underfits. Too big, overfits unless regularized. Dropout rate randomly drops neurons to prevent overfitting. Typical values, 0.2 to 0.5. Epochs controls when to stop. Early stopping, practical necessity. Model-specific hyperparameters. Examples: random forest, number of trees, max depth. XG boost, learning rate, number of estimators, max depth, gamma. Transformers, number of heads, embedding dimension. The 4 major techniques for hyperparameter tuning. Grid search, brute force all combinations. Pros, systematic. Cons, very slow. Example: learning rate, 0.1 and 0.01. Batch size, 32 and 64. Total, 4 combinations. Random search. Pick random combinations. Surprisingly effective. Benefit: explores space faster than grid search. Bayesian optimization. learns from past results and predicts promising hyperparameters. Uses: Gaussian processes, surrogate models, expected improvement. Analogy: like tasting a dish and adjusting seasoning intelligently, not randomly. Hyperband/ASHA optimizes resource allocation, quickly stops bad hyperparameter settings, perfect for deep learning. Real-world example: tuning an image classifier. Scenario: you want to classify images of dogs versus cats. Key hyperparameters tried: learning rate 0.1, 0.01, 0.001. Batch size 16, 32, 64. Dropout 0.2, 0.4, 0.6. Observation: best accuracy came from learning rate 0.001. Medium batch size 32. Dropout 0.4. Why? The model learned steadily without exploding and resisted overfitting. The future: hyperparameter tuning and AI agents. Modern workflows: AutoML, reinforcement learning-based tuning, model tuning as a service, evolutionary algorithms. An AI tuning agent can run 500 experiments, 20 hyperparameters, across multiple GPUs. This is the future. Models optimizing models. Hyperparameter tuning feels like mastering an art form. You adjust, observe, refine, explore. And every improvement, every jump in accuracy comes from your ability to guide the model. This is where practitioners shine. Models today are powerful, but the people who can tune them, they are irreplaceable. See you in the next one.